Please join me in welcoming the chair for the session, Ms. Anita Gupta, Scientist Chief from DST, Government of India. Ma'am, please join us and grace the stage. Moderator of the session, Shri A S Kushwah, former Director UPSLDC. Please come on the stage, sir. So we have theme presentation by Mark. He'll be joining us virtually. Miss Jema from Power Ledger, she'll also be joining us virtually. May I kindly invite Sridhar Venkat from BRPL. Thank you so much, sir. Welcome. Shri Atul Bali from ISGAN. Shri Shailendra Nathani from Impressa.ai. Please join us, sir, on the stage. Mr. Dan Travers from Open Climate Fix. Please come and grace the stage, sir. Shri Gaurav Kapoor, Vice President, Tech and Yacht. May I have Gaurav Kapoor, please, on the stage? Shri Vijayan SR, consultant from Hitachi Energies. Ms. Anamika Bhargava from L&T. Welcome, ma'am. Shri Om Krishnan, Scientist G from METI. May I have you on the stage, sir? John Grims from Smart Energy Council. Welcome, John. Dharamveer Singh, founder and CEO, Power Exchange. Thank you so much, Dharam, for joining us. Shri Vasu Khurana from Phoenix Contact. Please join us on the stage, sir.
So, good afternoon, everyone. I am Dr. Anita Gupta. I am Head of Climate, Energy and Sustainable Technology from Department of Science and Technology. So, welcome all the panelists and the moderator for this session, which targets on the emerging digital technologies for utilities. I think in the previous sessions, all had got a good glimpse of the kind of technology integration which is happening to make our grids more smarter, resilient, safe, secured, and also stable. How many of you remember the outage we had in the July 2012, the grid failure, northern grid failure? And what was the disruption in the normalcy it caused, be it like railways, transportation like railways, it carries so many passengers, hospitals, and what was the disruption of a common man, life of a common man. And I think that gave the food for thought how to really make our grids more secure, and that gave the birth of a mission, National Smart Grid Mission in 2015. At the same time, in 2015, our Honorable PM coined a new program, which is Mission Innovation. It is a multilateral platform of 23 countries and the European Commission, where actually these countries, 80% contribute to the global GHG emissions. And therefore, it is paramount and responsibility of these nations to come out with new technological solutions to catalyze R&D for clean energy transition. And DST happens to be driving mission innovation from India's side, and I happen to be part of the steering committee of mission innovation. So we have entered into the phase 2 of this mission innovation. 7 missions are underway. One of the mission is Green Powered Future Mission. And under that, how do we integrate the variable sources of energy, the renewable ones, and how do we really enable our grids to be more responsive, coupled with the energy storage systems, because These variable sources of energy are intermittent in nature. So this has become, I think, in the recent policy shift also, 10% like BESS is also being made sort of a part of it. DST has been actually in the forefront of spearheading the research and development in the variety of domains of clean energy. And we have leveraged the partnership, cross-border partnership, be it UK, US, or EU in a big way. And what we have done as a part of our core activity, we have piloted many living labs and test beds where we could really successfully demonstrate integration of these VREs, whether it's a solar, wind, biomass, or biogas. And we have enabled some of our communities which are in the far-flung areas of northeast, east, who are devoid of grid connectivity. And we have really enabled through microgrids. So there are many interventions with IIT Delhi, IIT Kanpur. We have come out with distributor operating systems. DSO has been report, roadmap white paper has been launched. I think going forward, really, we need to engage with industry, the utilities, and all cross-section of stakeholders in a big way, really to come out, because we are aspiring. We have set targets for 2030 as a part of national determined contribution. How are we transitioning towards cleaner and much more integration of REs, 500 gigawatts of REs has to be integrated. And how do you really make these grids secure? And I think technology could be the major, we need to leverage it in the meaningful way. At the same time, we really want to be self-reliant. We want to build up our own technological solutions, because in the geopolitics domain, technology sovereignty has become of utmost importance. So that's why whatever solutions, it is integration of AI, ML, blockchain, robotics, cobotics, digital twin, everything requires, we need to build up indigenous capabilities, but it needs to be piloted at, you can say, some grid level. And that's why we can build up and boost the confidence of industry, investors, and consumers in a big way. With these words, I think I would look forward to the takeaways of this discussion, which we could really integrate in our new program offerings for the interest, because by 2047, when India will turn 100, we want to be energy secured and independent nation. Thank you.
Good afternoon to all participants and the speakers. I am A S Kushwah. My association with this segment of power sector, that is deployment of IT system for system operation, is started in late 90s when we started implementing the ULDC project in PowerGrid. And I have seen that how productive this system is there. So it's around 25 years, it's a long period. How the industry has changed, how the products have changed. But at the same time, also being on the implementation side, I have seen how difficult is to deploy them in the power sector. Of course, grid disturbance, which are referred by Madam, that was one incident. And thereafter, and even after deployment of upgradation of the SLDCs, RLDCs, grid disturbance has considerably reduced. And of course, we are getting again apprehensive because of this energy transition which is going on throughout the world. And in India, we are on a forefront. In fact, among the leaders in this sector. So the present discussion, which is on basically digitalization, I think all the speakers here, we would be able to come out with some conclusive remark or conclusions which can, industry take away, as well as the DST, which is supporting in this sector, especially in distribution sector. They have also published a report for establishment of distribution system operators. And probably that is need of the hour, and we need to deliberate on that and how best we can deploy the new technologies based on artificial intelligence and so many associated products. And in this time of energy transition, there are so many utilities, who are working in this sector, and we are grateful to ISUW that they are making all efforts to bringing all the stakeholders on one forum, and we know so that we can know the product and what is the utility of that to which segment of the power sector. With this, one of our speaker, I think he is in hurry, he has to catch a flight. So I would request him to first, he could be the first speaker. I think you are the one. Please.
Mr. Chair, thank you. Madam Gupta, thank you also for the very kind introduction. So the Prime Minister of India, Prime Minister Modi, met with the Prime Minister of Australia, Anthony Albanese. And Prime Minister Modi said, I'm so excited, we're doing a 10 million rooftop solar program in India. And Prime Minister Albanese said, well, that's great news because in Australia, we have already installed over 4 million rooftop solar systems. We've learnt a lot over the last 16 years about how to do safe, well-designed, good-performing solar installations. And so the two Prime Ministers agreed that this would be an area of strategic cooperation between India and Australia. I love that. Because it's something practical. It's something taking the knowledge that we've gained in Australia and helping transition India so rapidly, so big, in such an exciting way, actually means there's a really great opportunity for business, for government, but for the people who will use the solar energy. And so, because we in Australia have won the gold medal when it comes to the amount of rooftop solar installed, we have the highest per capita solar installation anywhere in the world, but we're a small country. To collaborate and bring expertise to India to help...
That deserves an applause.
And it's very exciting. So, with the help of the Australian government and the Trade Council, the Austrade, the Trade Association of Australia, based here in the High Commission in Delhi, we've brought a delegation of 15 companies to India. These are companies that have experience in the digital field in distributed solar generation. We have a company that has over 50,000 solar systems under management in real time, watching the production, but also providing a service to the customers to turn the load on, to turn the load off, to use that solar energy for maximum economic advantage. We have companies that have installed thousands of systems at very low cost, but very safely and to very high standards. We have companies that are experts in power electronics. We have companies that are experts in modelling the impact in areas. In South Australia today, at times of the year, more than 100% of the electricity requirements for the whole state are met by rooftop solar alone. Not big solar, not big wind, rooftop solar alone. Imagine the challenge for the distributed energy service provider. Suddenly, they have backward flow of energy on 100% of the substations and feeders in the network. That's a big technical challenge. If you asked them 10 years ago, is it possible? They would say impossible. but actually it is possible. They learned how to do it. That is expertise that we in Australia want to come and share with our Indian counterparts and friends. So my invitation to you is, please, I think we've got a representative from Austrade here. Is it okay if you stand up so people can see? So we have the local hero here is the point of contact. We have the ecosystem in Australia, which is the resource base to connect the two sides together. Can I also, not all of the companies here, but can I get the Australian delegates also to stand up so that we can see the delegates here? Great. With real... One grid, one sun, one common future, Australia and India making it real. I'm sorry that I can't stay for the duration, but I'm looking forward to getting a briefing on the key highlights of this session and indeed the conference, the Smart Utility Week 2025. And for us, this isn't the end, this is just the beginning.
Let me just add one thing. So thank you, John Grims, for the wonderful overview of what Australia has done, remarkable feat in this solar penetration at the household level. I'm in touch with your Honorable Ambassador Philip Green, and he has offered a lot of, because I visited Australia last year only, some of the institutions who are doing really groundbreaking work in bringing out the new innovations in RE domain. And we love to partner as a part of international collaboration, as a part of Clean Energy Ministerial, what you highlighted, like one sun, one grid, and one world, is the overarching ambition for us to arrive. I think through mutual collaboration, whether it's at the national level, at the international level, I think we need to strive for that mission.
Thank you. And sharing with us the importance of the rooftop. I think in India, I think that globally the contribution of rooftop in solar energy is almost 40%. And India, we are slightly lagging with that, and hopefully with the PM Sur Yojana, we would be catching up to the world level, international level.
In about 3.5 minutes, you will be the big player globally.
Thank you. Now I think. Now I think there is a presentation which to be made online, virtually. So could you please facilitate?
Hi, Mike. Hi, Mark. Can you hear us?
I can hear you fine.
Great, great. You can start with your presentation. Or, ma'am, would... Okay, yeah, you can start with your presentation, Mark.
That's great. Thank you very much. I really appreciate the invitation to participate remotely. I wish I could be there. It's such a great conference and gathering of distribution experts in India and from around the world. And it's such an important time for developing the electric utility network to integrate more renewables, as we've just discussed and heard from Australia, and to make a power grid that can handle that and support that. And the topic of digital technologies that are making this possible is a very important one. And I wanted to highlight 3 important collaboration areas that are going on at EPRI that I think that can really contribute to this effort in terms of what's going on around the world in this space. And you know, I'm from EPRI. I'm located in our Dublin, Ireland office. as part of EPRI Europe, coordinate with the larger EPRI, where we have over 1,400 technical folks working on the power system of the future. And as we look at the grid and digital technologies, I think a couple of important areas are really critical. And the first one I wanted to mention is grid enhancing technologies, taking advantage of technologies that can make our existing grid work more effectively. And there's four important categories, of these grid enhancing technologies that we're looking at. The first is dynamic line ratings and taking advantage of sensors and information communications to get the most out of every transmission and distribution line that we can get, to not just arbitrarily assume that a maximum rating for a line is a certain number of amperes or megawatts, but looking at what line can handle at every moment in time based on wind conditions and temperature conditions and existing power flow levels and so on. So a lot of technology development in that space. Another important category is what we call power flow controllers, using power electronics to direct where the power goes in the transmission system. And there's various kinds of these power flow controllers, but power electronics will be playing a big role in the future as well. And the third area of grid enhancing technologies that takes direct advantage of communications and intelligence regarding the overall grid is what we call topology optimization, or being able to actually switch lines and direct flows on a transmission system to optimize the use of the existing grid. And these are examples of technologies that we've had for a while, but communications and sensors and intelligence, including artificial intelligence, makes them even more effective. And EPRI has a large collaborative around accelerating the adoption of these technologies by laboratory tests and verification of the performance of the technologies, like the sensors and the power flow controllers and technologies that are used for dynamic line rating and so on, and then actual deployment and demonstrations and documenting performance. So that's an important collaborative effort around these grid enhancing technologies. The second category that I wanted to talk about is flexibility, getting flexibility from distributed resources. And this has been a big part of the Australian success story that we just heard about. And we're trying to take advantage of this around the world. And the key to it is interoperability and creating frameworks and standards for the interfaces between devices that may be in individuals' homes, the smart inverters, energy storage, batteries, electric vehicle chargers, heat pumps, air conditioning systems. All of these resources can be controlled and managed to provide flexibility for the grid, but we have to have standards and protocols for doing that. And we've got two large collaborative projects that are working towards that. One's called the Mercury Consortium, which is an effort with vendors, aggregators, utilities, both TSOs and DSOs, to define the basic requirements for the devices, for the electric vehicle chargers, for the heat pumps, for the batteries that are in people's homes. What are the requirements for those devices to participate in grid services? And we'll be developing specifications for certification tests for those devices and the frameworks for the interface between aggregators or home energy managers or utilities and those devices. So that's at the device level. And then at the overall framework level, we have an initiative called Flexit that is looking at the interface between the utility and aggregators or direct control of those devices, what it looks like at the kind of the DERMS level, the distributed energy resource management system level, to manage all of those resources. What does the framework for that look like? What do the protocols look like? There's a few different ones, OpenADR, IEEE 2030.5, that provide a framework for talking to those devices and managing the information flows, and standardizing that approach is part of this effort that we call Flexit. And of course, the final technology that is changing the way we operate in every aspect of our lives is artificial intelligence. And I'll just mention that EPRI's created, along with Microsoft and Google and some other large players, including NVIDIA, an initiative that we call the Open Power AI Consortium. It's a worldwide initiative. It doesn't cost anything to join it, but the idea is to have an open source platform for developing applications that can support the power grid and the power system. We call these small language models rather than large language models, and take advantage of data repositories that we could use to train these models, as well as expertise from utilities and from EPRI and from other research organizations to provide feedback to these training systems to make these applications more effective. So watch for information about that, the Open Power AI Consortium. We look forward to working together with researchers and utilities and technology developers in India on that initiative. So really look forward to the discussion and ongoing cooperation in this space. Thank you very much.
Thank you. Thank you. Would you take on the questions if there is any from the audience? I think he's not able to listen.
Any questions for Mr. Mark from audience? Don't see any questions.
Okay, thank you.
Okay.
I think you have
Thank
very
you,
well
Mark.
explained. No clarification further needed.
Thank you very much.
Thank you.
Thank you. So, yes, very well explained. I think what is going on, what the product are being developed. In fact, if you see the background, it is in respect of the energy transition. Traditionally, the grid is designed for generating power with rotating machines. So they have a lot of, they have few inherent properties which keeps the grid stability, and one of them is inertia. Then the rotating machine, they have the governor, which can control the speed of the machines. And then another is AGC, automatic generation control. And in addition to that is in the conventional system, the fuel can be stored, and it is stored. And you can control the generation. You can generate when the demand is high, or you can reduce it when there is no high demand. But with the change in with the upcoming new, renewable energy like solar and wind, those are all static. So the static devices, they have to represent the similar characteristics which are there in the rotating machines. The products which are being developed by many of the utilities, they are basically trying to fit into that grid operational requirement. So I think many of the utilities who are doing this, one or the other way, they are coming into that landscape, grid operational landscape. And in coming back to our DISCOMs and deployment of the IT technology and digitalization, in fact, this process in the country has been started along with the APDRP, which was there in 2002, and started in 2002 or 2003. And many of the organizations has come up. ISCF is one of them. NSMG is government, set up by the government, and then international organization is gone. These they have doing a very good work helping the utilities, and many of the utilities have come up. They have taken the lead in adopting the IT systems. And for operational purpose as well as for business purposes. Mr. Bali is heading NSMG, National Smart Grid Missions, and this organization is there, I think, is more than 10-year-old now. And he is also in a vice chair of the ISGAN. I would ask him to just share with us what they are doing and how they are helping the discom utilities and what is their guidance suggestions for the companies.
Namaskar. Thank you, Kushwah ji. And it's a privilege to be part of this esteemed panel. And I'm also fortunate to have Shri Kushwah ji as our moderator, since we have long worked together in the ULDC program in the PowerGrid, and this one nation, one grid, one frequency, that the concept of future, what we have realized in 2013, I think Madam Anita ji was referring to the grid interruption of 2012. And I think after 2013, we are working in one frequency, and there is nearly 1 lakh megawatt of exchange capacity already available in our grid, and that is able to match and balance our grid in a very, I think, stable manner. Definitely the IT interruption, whatever you may like to call it, that started from RAP-DRP nearly from 2009, and I'm happy to share that I was part of this journey since beginning, and part of this process which made this happening of India Smart Grid Forum as well as India Smart Grid Task Force, which are other transformed into National Smart Grid Mission in 2015. And also India is one of the founding member of ISGAN, International Smart Grid Action Network. And presently, Indian representatives have been part of this presidium also. Now I'm a part of that presidium also. That smart grid journey, and particularly in Indian context, we have been able to test these technologies, but we call it smart metering and AMI and PLM. And we tested that through our pilots across the different states with the different geographical backgrounds and different technologies we have tested. All type of communication technologies been tested, and we are able to successfully demonstrate through the help of these key innovation technologies that smart grid is a real journey which we are moving ahead with. And in that case, of course, along with that, not only the technological advancement like smart metering or technologies in the communication era, like we have been depending totally on the GPRS, along with that RF along with the GPRS. Now, I think that is the basis on which we are able to demonstrate or rather implement this smart metering across the country. And a large, you can say, the national level program is already under implementation, where we are going to deploy nearly 25 crore of smart meters. As 25 crore of smart meters, this deployment is unique in the entire world, and that is a unique implementation going on in the country. And nearly 2.3 crore smart meters have already been deployed, and that have been deployed based on all type of feasible communication technologies that are deployed across the globe. And the criteria, I think not only the technology, the business model has altogether changed. I was there in the earlier session, and I think there was a talk of suitable business models that need to be adopted. How the CapEx model would be able to demonstrate that, or we have to change that, because ultimately technology along the business model will pave the world. And that's why we adopted the TOTEX model, the OPEX model. And that OPEX model based on SLA-based performance, technology agnostic, based on standardization, based on interoperability. That is the key governing parameters that is going to take us forward to the smart grid journey. If we take the case of smart grid in India, we are very well now able to demonstrate basically the use case of smart meters. And smart meters as a key element of the smart grid journey will be able to demonstrate these factors. And as we have seen that through the journey, that if we go with the injection of the too much of DER and everything in that place, so definitely with the prosumers coming in field and too much injection, whether it is through the solar, whether it is through the wind, or whether it is through the EV and other things coming into the arena, we need to have the visibility of the data. Visibility of the data and the tools to manage that. And in that case area, not only the smart meter will play an important role, but altogether we have to use the data. And there the data analytics and everything has to come on board. Along with that, the utility has to take these challenges and adopt the new technologies. New technology, when we talk it, not only the AI and other aspect altogether, but also the predictive maintenance of the equipments at the substation, interoperability of the different IT/OT system. And from that aspect, I think even the ISGAN, if we take the ISGAN as a, recently in the last year, we have done a collaborative workshop along with the different countries and different stakeholders there in between. And of course, some message points have been developed for the key transition to happen in the area of the smart grid. And that is basically termed as the message to the key decision makers across the different countries, that what are the elements or what are the key criteria to be taken forward, which can be helpful in the demonstration of the implementation of the distribution grid, smart distribution in the future. And that one important aspect was an environment where the investment would flow. Environment where all the technology players, whether all the stakeholders can participate in a manner in which they can deploy the technology, deploy their elements, and they will be rest assured of the investment or return on the investment also. And of course, another aspect was participation with all the stakeholders. When we talk of the distribution planning and its implementation, stakeholder importance is very much important. Take the case of smart metering again. If you have to utilize the smart metering in two aspects, not only of the basic low-hanging fruit of the reducing the AT&C losses and other things as such, but using the TOD, demand response, DERMS, and of course all these things into play. Then everybody, regulator should be on the board, DISCOM should be on the board, technology players should be on the board, and of course the investment being put up by the different stakeholders, they should also be on the board. So that is the basic criteria, premise on which the smart distribution grids or the grid would be built on. And there is the look forward basically in that respect. And even in the RTS, what we are talking of the rooftop solar, and too much injection onto that, and PM Surya Ghar Yojana is already, I think, in the March itself, nearly 10 lakh solar homes already been charged. And they is basically utilizing subsidy, and of course, that will be injecting the another DER. And that's way to move forward. Even in that respect, energy, rather the real-time energy interactive buildings, green energy building, what we are talking about, that also sees the light of the day. And in that case, aggregators. When we talk of DERMS, we have to have the players, because what we have done, I think, recently in another seminar, we have been discussing with Tata Power, and they were demonstrating nearly in 15 demonstrable use cases and the 15 events, they have been able to shed nearly to the tune of 500 megawatt of energy. You can utilize the potentiality and the potential of that, but that has been tested as just a use case, or you can say a pilot in which no benefits have been passed on to the end consumer. But even they have been able to demonstrate by keeping them on board. But if you have to have the commercial aspect in that aspect, you have to have to commercial viable, then I think we have to have aggregators on board, we have to have a policy in board, we have to have regulators on board, so that it should be commercially viable and people should be joining in that. In that respect, we have already, from the Ministry of Power, we have sanctioned certain smart distribution projects to the utility, like in Varanasi, Noida, Gurgaon, and even we have already developing on the other utility, we have taken forward the smart grid initiative. There we also be with sanctioning. But in that case also, we need to have the collaboration in that respect. So I think coming from the basic and aspects of the moving forward in this integrating of DRs and smart grid initiative, I think first moot point will be all stakeholders joining together and utilizing these all technologies and looking forward to adopting and implementing in a unison manner. That is, I think, the starting points I would like to share. Thank you.
Thank you, Waliji. There may be a few questions to Mr. Atul Bali, because he is representing a government agency. But I will request you to hold on. One of the speaker, she would be online. She is waiting. I think I just missed. And I thought I couldn't realize that she is already online. So please ask.
Yes. Please connect Gemma. Huh? Yeah, okay. Hi, Gemma. Welcome.
Yeah, welcome.
And I'm sorry I can't be there in person, but I really appreciate the invite and the opportunity to connect via video conference, and sad that I'm not there with you, especially to enjoy some amazing Indian food. I think the landscape with energy is very much driven by conversations around electrical engineering, as we've been hearing as well, but also the political landscape. And I think that AI was mentioned as well, and there's a big race to build more cloud capacity to be able to power those things, and the countries that are able to bring more energy online quickly are going to be well placed to participate in those new economic opportunities. And the countries that are slower to integrate renewables and new generation and install capacity online will not be able to buy it for the piece of that pie. But equally, strong demand pushes up price, and we talk a lot about energy transition, but actually we're in globally a state of energy expansion as we consume more energy each and every year, and new sources of energy that come online are really adding to the mix as opposed to replacing anything that is already in the generation mix. And I think that's quite an important point to make, because the kind of notion of an energy transition is a bit of a misnomer. And if you look at the Indian context, the Indian government has set ambitious targets for renewable energy all round, but I just wanted to take a few moments to focus on electric vehicles. The target from the government in India is for EVs to make up 30% of the total passenger fleet sales by 2030. And according to S&P Global's estimates, India's EV penetration rate has grown modestly by about 200 basis points annually from like 2021 to 2024. So it's really, to achieve that 2030 target, the growth rate must nearly double to get there. And so it's going to be very interesting to see what are the things that are going to stimulate that, and what will that actually look like in practice. And at the moment, the target is looking to be just slightly under 20% of total passenger vehicle production by 2030, and that accounts for about 1.3 million vehicles. And in terms of like the challenges in EV adoption, I think the reliance on imported batteries and components is a challenge. Charging infrastructure, especially in the tier 2 and tier 3 cities. And there's also concerns around greenwashing, around how things are charged, how vehicles are charged, and the demand for verifiable renewable energy. Part of the story with EVs is, air quality, particularly in India, but the other part is what's being used to power the vehicles. And I think the government incentives focus on 2- and 3-wheeler vehicles, and passenger EVs lack quite a lot of direct subsidies right now. In terms of like the challenges around renewable energy, there's like a kind of EV green energy problem is what I would call it. And it's where EV charging doesn't always align with renewable energy availability. And there's not like a tracking system to be able to validate what's the provenance of the energy. And we've developed a solution for a European client that needed real-time energy tracking and transparent carbon footprint assessments. And what that can actually do is provide traceability and certification of the energy used for EV charging through real-time tracking of the energy mix for green energy products. So it records and displays the provenance of electricity produced, the quantity produced in a time period, and the meter producing the energy and the type of the energy source. And it tracks the quantity of electricity by each EV charging station within like a specified trading group as well. And that assesses the quantity up to the kilowatt level of precision. And the client and the authorised users can view the agreed EV charging rates and the consumption generation data for each charging station. and it can generate a statement of use at monthly or quarterly time periods, and provide downloadable statements and allow the purchase and retirement of renewable energy certificates to top up for any gaps where energy is being sourced from non-renewable sources, but there's a desire to purchase be 100% renewable. The system can take account of that. And I think that, to the extent that there is not just a desire for EVs from whatever source of energy, I think this can be quite an interesting use case in the Indian context. And many of you will know that we use blockchain technology, and what we do with that is really it's really for tracking each kilowatt hour of energy in terms of type, time and place, especially given there's so much greenwashing that we see today with false claims being made about the provenance of energy. And I think that using this technology increases trust and confidence in what's being sold and allows potentially premiums to be charged. But I would actually say that the cost of energy now with renewables in many cases actually cheaper. And so it allows more attractive commercial offer to be made at a lower cost, and the claims about the renewable energy to be validated. And there's benefits, I think, all round. In terms of the EV fleet operators, they can achieve their sustainability goals and optimize costs. And for charge point operators, they can differentiate their product with verifiable renewable charging. And for energy suppliers that are participating in that ecosystem, they can balance supply and demand and optimize clean energy supply. And then for the users themselves, they can charge smarter, so they can know where to charge and how they can optimize for both cost and also clean energy outcomes. And so I think in terms of all the kind of stakeholders in this, there's benefits to be had. So in terms of blockchain, it really is about tracking energy mix in real time. It can enable 24/7 renewable energy matching for EV charging, and provides verifiable proof of clean energy use. And it can also support dynamic pricing based on green energy availability as well. And I think that ultimately this can really catalyse a behavioural shift and incentivising users to use clean energy for EV charging, I think, which is important, especially given the ambitious targets that India has set and the need for really encouraging faster adoption in the market. So, on that note, really appreciate the opportunity to be part of the panel and look forward to the Q&A.
Thank you. Any question from the audience or from the speakers? Okay, thank you,
Thank you, Gemma. Right now, we don't have questions. Thank you. In case there are, we'll write them to you in case there are any questions. Thank you for joining.
Thank you.
Thank you. Mr. Sridhar.
In India, we have, I think, around 70 distribution companies, and out of that, I think 17 are private discoms, and others are government, if I'm correct, Waliji, I think. This daily distribution system, I think this is the only one which has been privatized by the government in India so far, and successfully privatized. They started, I think, in 2003 or 4, first July 2002. And the first thing which they did, they started implementing the IT-based project. In fact, from PowerGrid side, when they first installed the SCADA system, we provided technical support to them, and I was one of them. And yesterday I've seen a presentation in this forum, only similar forum, made by BSS, and they have a remarkable achievement. I think everybody need to learn from this process of how the privatization has benefited the consumers of Delhi. They have considerably brought down their losses. They are ready to implement any IT-based project, technology, artificial intelligence, or anything like that. And so we are fortunate enough to have Mr. Sridhar. He is a network operator from VRPL, and let's listen to his views.
Hello. Sorry, my throat is bad. BRPL is a leading power distributor. Can you make this mic is on? Yeah. We last year provided 3809 megawatt of thermal power supply, peak power, and Delhi 8656 megawatt. This year we anticipate 9000 megawatt of Delhi and BRPL at 4050 megawatt. As a leading discom in the capital, and we believe in customer excellence, delight, and also uninterrupted power supply with safety and quality, with the health of employees and happiness of employees. And as thank you, sir, for saying that we have done SCADA and you helped us in the initial days. From 22 years of power supply and privatization, we have done a lot of digital introductions, and earlier presenter, Mr. Vishnu Srivastava made a beautiful presentation on how technological things we have done. And if you look at it today, we are at 6.2% and ETNC loss level from 54% we have brought down. Similarly, Yamuna has brought down from 63% to 6.2%. And we constantly working on the technology, digital delights, which we have for our customers also. AI, we have, and ML, robotic process automation, or blockchain technology, we have been using it in our organization. Last year we introduced customer care chatbot, and where in fact we were able to get a lot of complaints registered. Apart from our various Twitter, Facebook, WhatsApp, and call center and IOMS based complaints. So we are able to give a customer delight, because Delhi's customers, our expectations have gone up like anything, and we want to give them value-added services by technology. Similarly, on the machine learning, and as you rightly said, the customer SCADA and other aspects where we also introduced on the power performance optimization by short-term power purchase using blockchain technologies, and a lot of routine processes we have made, robotic process automation processes, we have made it a wonderful journey. Yeah. And the cloud computing, and we are moving towards cloud as a private discom. And in the training, we have used virtual reality and augmented reality for our ECBs and RMUs, so that our end employees, lineman, helper, and fitter supervisor, they use the technology for and also get the maintenance very nicely done. Blockchain we use for power tracks in our short-term power purchase. And cyber security, we are working very with the government and with MIT, and we have CSOs and deputy CSOs, and closely addressing the issues. Last time G20, we have addressed the 3,500 odd cyber security threats which had come during the G20, and we have overcome those threats nicely with our IT interface. And the big data, because Discom 31 lakh consumers, out of that 28 lakh consumers are domestic consumers, and around 10,000 odd are KCC consumers. We use R, Python, and Tableau for our big data, because we strongly believe we have to add value, because of veracity and velocity and the variety and the volume. Unless we add value to the customer, Discom's presence has to be there. SCADA Live, we have created technical feasibility, new connection modules. Any consumer we are applying for a connection, we want to give them seamless, smooth process. We are evolving and improving, and also the maintenance practice OPM, online preventive maintenance modules, and predictive maintenance as well as proactive maintenance. We started using drone for our EHP as well as HV systems, where in Dwarka and bigger system we had on the vegetation management. We use technology for identifying the various processes and improve. And meter, we also have a technology-based thing. We use extensively GIS, and the Alexa also we have started using for latest electricity bill and the bill due date and the previous 5 bills and nearest cash and also e-bill. Your customer can get the delight. And digitalization, decarbonization and decentralization. We are having a roadmap prepared for our energy transition, and because without digitalization and decarbonization, and because ESG is the frontal prime of our DISCOM, because environmental social governance, because we as a DISCOM, we are already 50% our energy portfolio will be green by 2026. We are already at 36% now. And the PTR health index monitoring, we already started for our EHV grids, wherein we are measuring the predictive life assessment of the PTRs based on their oil and other properties. And we have test data which are and also sensors, and we are using for IR and WRM and death rations and other 10 delta and your values for measurements for oil. So how can we prevent transformer from failing, and we can always do a proactive aspects. We also started doing data lake for advanced data analytics and digital twin LT network. Vishnu has said last presentation. We have started beginning with Venus and Terry and participation, and with also Panatech Power. We have done a lot of proof of concepts. Now your time has come for us to expand and go in a bigger way, as we are going for a best battery energy storage system, 20 megawatt for 20 megawatt and 40 megawatt hour at Kilokuri. Tata has started 10 megawatt hour. We are doing for 20 megawatt and 40 megawatt hour for peak saving, and also the ADR and the advanced automated demand response. We are also working on those aspects, and DSM, demand side management, so that how technology can yield customer delight and customer experience, and also at the same time our employees and who are working also with a healthy and happy manner can deliver the better services for the Delhi customers, because the expectations are going up day by day, and we as a DISCOM with a digital intervention we will be able to give much better delights and value-added services. Thank you.
Thank you. Thank you, Mr. Sridhar. Now next I will invite Mr. Shailendra Nathani. Mr. Nathani, I am not very well aware about your organization, so please introduce yourself and also let us know about your organization and whatever else you can share.
Sure. Good afternoon, everyone. My name is Shailendra Nathani. I work for a company called Impressa.ai, and I work for product strategy. Impressa.ai is a new age company which is based on the AI platform. And we have built these products and solutions for the utilities industry. And in today's session, I'll basically talk about 3 emerging technologies which will shape the future of utilities in coming years and decades. So the 3 key technologies what we see are how we can improve the asset resiliency and asset efficiency. So we'll see that in the coming times, the asset infrastructure will go towards self-healing assets, right? Where AI will be used for anomaly detection. Not only detects the anomalies, but it also initiates the workflows and corrective actions to put the asset back into action. So we will see the use of AI where the entire workflow gets more and more automated with less human intervention. And this is happening. We'll discuss one use case. Next slide. This will lead to reduced downtime and reduce the operational cost, which will make the grid more resilient. The second technology which we see is the decentralization of the markets, where lot many distributed energy resources will work in a more cooperative, federated manner, where the contracting processes will become more transparent, more efficient with the use of blockchain technologies. We have previous speakers have talked about that. So this is one of the new emerging technologies which will bring transparency in the whole system. Third, key technology, what we see is the hyper-personalization of customer engagement. When I say hyper-personalization, we would see the use of AI in giving very personalized content in the form of product and services to the consumers. We'll see the use of bots where the consumer, there will be personalized interaction with the consumer, and we'll talk about in subsequent slides how this is happening as of now. Now, for the utility companies, how can they imbibe these emerging technologies? So there are three specific action items. One is we have to define well-defined asset and network standards, and we see that there is a big challenge in the utility industries in mapping these assets and network in the existing GIS systems. That's a big area of concern. And previous speakers have talked about the data lakehouse, and it is very important to build up an operational data fabric which can ingest data in real time and provide real-time event detection and automated decision making, right? It's not just important to set up a lakehouse, but also set up the intelligence layer on top of that. As a part of Impressa.ai, we have a solution called Impressa Asset Insights, which we have used in one of the largest transmission companies in India to get the data from all of the OT systems, including SCADA, GIS, gas analyzers, and things like that, to put that into a corporate data warehouse, which is a lake house, to generate real-time asset insights. Second area is, as I talked about, the use of blockchain technologies in smart contracting, and this will be based on open protocols where data exchange happens in real time between the various agencies and using open standards. So in Impressa, we have Impressa Grid Insights, which looks into these requirements. Third and most important thing is how the virtual power plants and even the consumers will interact with the DISCOMs in near real time in resolving their issues regarding services, or the DISCOMs can offer them very personalized services related to demand side management, or in case of APPs, resource aggregation and things like that. Impressa provides a solution called Impressa CX, which is a digital customer engagement platform, which uses agentic AI-based technologies where intelligent routing of the customer request can go to the right agent with the right knowledge base, because we know that there are call centers which work in specific times, but if we want to operate 24/7 with the most efficient resources, we have to use AI in routing to the right agent and knowledge resources. So let me take an example of a self-healing asset. Maybe this is an example of a transformer, and we know that transformer these days can be monitored, the performance in real time using a lot of sensors which can monitor temperature, voltage, current, oil levels, and any other parameter on the transformer. This can be monitored in real time, but the main beauty is that once an event is detected, right, what do we do with that event, right? Many times the event may be logged in a data logger, it may be logged in an OT system, maybe we can create alarms and events in certain cases and route them to technician who can work on that. So in a in an automated system, how it will work is that you will always evaluate the severity of that event, right? It's not that every event has to be acted upon in near real time with the right technician. You will identify what is the severity and impact of that event. And then based on preset AI-based algorithm rules, you will decide what is the right corrective action for that event, right? You may, for example, decide, hey, is the event very critical? It is likely to cause a cascading event where other related equipment may fail, and what is the financial and operational impact of that event? And then based on that, the AI will decide what is the best possible action for that. It could be maybe, initiating a cooling system, activating a bypass equipment, or maybe alerting a technician, or any suitable causes, right? The AI can take a decision on it itself, and then initiate that corrective action. And once the AI takes an action, then the AI model understands that for the future events, how to deal with these situations, right? It improves its model over a period of time. So this is how the self-healing equipment will work in future. Now let me come to the next use case of customer engagement. The customer engagement now and in going forward has to be an omni-channel customer engagement platform where all the channels would be integrated together. So there's no IVR system and web-based system or a customer portal or a mobile app. All has to work in a unified manner to give the a unified experience to the consumer, where all his requests would be routed to the agent, who is either sitting behind the desk or an engineer who will take a corrective action. So the channel will become 24/7. It will use AI as a backbone to, 99% time, it would be able to provide an immediate response to based on the information it already knows about the customer, his behavior or his action, or the information from the past corrective action. So it will become more automated, where the call centers would become more efficient, and it will give a very personalized experience to the consumer. Or maybe, let's say that we want to position certain DSM services to a particular consumer, we can know that what are his behavioral patterns and then provide the personalized service to the customer. It will become more AI-centric. So in Impressa, we have Impressa CX, which handles many of these things. It has an AI-based chatbot. It can work on it can provide support for net metering and energy efficiency programs and various other features which are required in this day and age going forward to bring discounts more closer to the customers, right? So the AI will be used as a layer where it can bridge that gap. So I'll just keep it very short because we have 5 minutes. So just to summarize, so there are 3 key takeaways. One is that the system reliability will be improved by AI using the self-healing infrastructure, right, which requires less manual intervention, where the system would be able to take a decision on its own and with interconnected assets. Second is the market efficiency, especially in the distributed energy environment, will become more efficient with the use of blockchain technologies. And third is the customer participation and interaction will become very, very personalized with the use of AI on a mass scale, right? So these are the key takeaways. Thank you so much.
Thank you. As informed by the organizers, we have to wind up by 2:30, ma'am. So I will ask each of the speakers not to take more than 5 minutes, 5 to 6 minutes maybe. So the next I will invite Mr. Dan Travers. Is he here? Yeah, please.
Thank you very much. Thank you very much for the introduction. Thanks very much for the previous speakers. Thanks to the audience for coming here. So firstly, quick introduction to myself. My name is Dan Travers. I am the founder and director of a company called Open Climate Fix. So we are an AI-based company doing solutions for the electricity grid. My background is in energy. I started in electricity in Australia, actually, so I was tempted to stand up as the part of the delegation. That was 20 years ago. Very much pre-renewables, so back then it was all coal. It was a little bit of hydro. The whole revolution hadn't started, and it is quite amazing when I go back to my hometown of Adelaide now to see the solar on my parents' rooftop, solar on everyone's rooftop, and South Australia, where Adelaide is in, is looking at potentially a net zero before 2030, right? Which is quite an amazing achievement. So it can definitely happen, and it's really exciting. And I think also India is in a similar situation with a lot of natural resources in terms of sun and wind. So what do I care about here? My first. Sorry, I'm just looking at my notes. So my first most exciting sort of connection, I think, is when I moved from energy, I moved into fintech, into working in Canary Wharf in financial markets. And if there's one thing that's more important than energy in the world, it's money. So people care a lot about money, and the financial markets are extremely well developed and very mature and very advanced in many ways. So I wanted to try and take a few lessons that I took from financial markets and also thinking about what we see as the challenges from the energy simulation point of view. The first one is financial markets talk about risk very natively. So financial markets are extremely used to talking about the concepts like a value at risk, which is one of the things that we used to simulate. So we would always talk to people about what's the 99th percentile chance. What's the 95th percentile chance of something happening? And I must say, in energy at the moment, we're still mostly talking about what's the expected result, and then what's the worst case. I think there's a lot of work we can do to connect through and put that understanding of risk through everywhere through organisations. So people are thinking about what's the distribution and what are all the possibilities. And you start to see this a little bit in weather, for example. So in weather forecasts, you often see a probability of rain. And I sometimes see people ask me, what does the probability of rain mean? What does that mean? And it's getting that understanding into everyone's head. So that's one thing I'd really like to see in the energy industry in the next 20 years. And I think we will move in that direction quite rapidly. The second one is, it's been mentioned before many times, is the huge explosion of data in the grid. We've moved from having tens or maybe hundreds of generators to having literally millions of generators on people's roofs, distributed throughout the low voltage network, as well as the rise of batteries, which can potentially use electricity but also push it back into the grid. This explosion of data is very exciting, I would like to say. It's very scary, but it's also exciting. So what can it do for us? Firstly, going back to the previously mentioned one grid vision from Narendra Modi, we don't have one grid if we're not all talking the same data language. If we can't communicate that data across assets with standards and across organisations, we're not really going to get to one grid. So to get to that one grid vision, we need to have interoperability between data, between devices. We need to have open data where possible. So one thing that is very observable in the UK from the fairly early privatisation back in 1989, this very good data reporting was established. So if you look at there's a website for the UK where you can look at all of the generation from the major generators down to 5-minute intervals, very transparent. Unfortunately, the grid code has not kept up with that level of transparency, and so the grid code has lagged behind the changes. So what I would really like to see, and I think there's some exciting stuff happening in India at the moment, is the grid code keeping a pace with the distributed energy resources that are everywhere, requiring standards for data to be communicated, requiring individual organisations to open up data where possible. Now, obviously, there are concerns about privacy, there's concerns about business models, but there are ways to anonymise data, and I think taking anonymised data and sharing it at the appropriate level will allow companies with amazing AI technologies and machine learning to operate. Because how does machine learning operate? who are the people who've got amazing machine learning algorithms out there? It's Facebook, it's Airbnb, it's Google, and what have they got? They have got huge data sets. So huge data sets across billions and billions of points. The electricity grid has got huge data sets, but they're not necessarily in a place where we can use them. So my vision is open data where possible. I think aided with government's regulation to require people to share data, and then standards to ensure that the data is shareable. And I think that will allow a truly one grid vision to take place. Thank you.
Thank you. Next, I will invite Mr. Gaurav Kapoor. Please introduce yourself, your company, and share your experience and your product, how it can help building up the smart grid.
Thank you, Mr. Kushwah. My name is Gaurav Kapoor. I am from the distribution background, so I have a unique, a little bit of experience in this field and have risen from the ranks, so I know what goes into the mind of people who are operating the grid. Recently we have been collaborating with Mr. Atul Bali for, this smart distribution project when I was with RTI. Very recently I have quit my job at RTI and joined Tech Uncorked. Tech Uncorked is something which you uncork a wine bottle, you uncork technology, and that the wine which can be used to for our enjoyment purpose, technology can be used for enhancing what the grid does. What we do is currently we have a product called LV IoT. So if you look at the grid, most of the innovations have happened at the EHT side. The grid at the transmission level is quite up to the mark. If you see, most of the technologies which have touched the higher end of the grid is SCADA, even a lot of IoT and AI has been, implemented at the transmission level. It's the distribution level which is lacking, and more so at the LV level, because that is the interface for the consumer. Your last mile consumer is hardly concerned if the outage is at 132 kV or 220 kV. It's mostly the LT outages that they are concerned about, and how do we improve lives for consumers at the LT level, at the level of a domestic consumer. That is something which our vision is, and our vision is outage-free electricity for all. We make this happen currently with our clients at Tata Power and BSCS Yamuna in Delhi. And our primary products are distribution transformer, health monitoring, substation monitoring. We are vendor agnostic that way, so we can take inputs from any kind of devices and show the utility as to how their workforce and their devices are performing. So taking a cue from cricket, because everybody in this country loves cricket, it helps the BCCI to see whether spinners do better in certain conditions, if fast bowlers do better in certain conditions, and this is some knowledge which helped us bring the recent tournament trophy as well. So had this knowledge not been there with BCCI, it would have been difficult to compete with other teams, which our team did very well. So similarly, we have a lot of data, as Dan said, in terms of electricity as well. We have so many devices connected, but what do we do with that data? We need to bring certain insights, just like BCCI is doing with data, as to whether we need a Rohit Sharma or we need a Virat Kohli in certain condition. So your workforce also needs your workforce has certain Virat Kohlis, certain Rohit Sharmas. So whom do you use, or you delegate a particular task in a certain manner? This is what we help our clients do. So our approach is usually to take a problem from the utility, a problem statement, articulate it, and then maybe try to find out what are the important data points that this particular problem, what will solve this problem, what will be the data points that will be required. Then we come to whether it can be solved with technology or not, whether it's kind of a cultural problem or whether it's pure play technology which will be required. And if it is technology, what kind of sensors and dashboards would be required. Then we use AI and IoT and do the solutioning part and come to the evaluation and improvement of that technology. So just to give you an example, what were the important data points for a particular, say, transformer management system. So we said that the system should be capable of providing some, rather than just showing the data that there were so many trippings at so-and-so point in time, which makes sense but does not take it to the next level. We wanted to be make it an analytical decision enabler, so that a person can say that, okay, I want X person in this particular subdivision to improve that subdivision, and then take it to the next level, handhold the other person coming in, and then transfer the capabilities. So say, for example, what do I do to increase do I increase manpower for mean time to repair, or are my devices not up to the mark? Which particular make of devices fail most? Those are the kind of insights that we provide. In interest of time, I'll not delve into all these, but these are the features of our DT Health solution right now. Just an example of the insights. So, for example, your district performed best in load balancing this month compared to others, and your mean time to repair is only so and so. You are only behind 2 hours on an average, so it gives you some kind of pointers. And for example, you could have performed better since you performed better previously. So, and you have to give people some pointers as to how their performance can be improved better. So this is a screenshot of our dashboard. It is role-based. It tracks KPI. Can you just wrap it up? Yeah. So I was coming to the last point. If you look at our country, these are the kind of DT failures that we have right now. This is only with single directional power flow at this moment. Just imagine when we have bidirectional power flows, where would we be? And currently we spend about 5,000 crores in failed DTs. Our solution offers a benefit to cost ratio of 1.92. These are some of our clients and some important milestones that we have achieved. That's all. Thank you.
Thank you. Yeah. So I will invite next Mr. Vizian. He is representing, I think, Mitsubishi, no?
Yeah.
Yeah. So, yeah. Hitachi. Sorry.
Thank you. Yeah, Hitachi S12ABB. Yeah. So that's always. So right now I am from Grid Automation Solution Architect from Hitachi Energy. So in the interest of time, I will not go through the slides. I have the deck shared, so I think it will be shared with all the participants. When we talk about the digital technology emerging, especially emerging technologies, so we know about the technology intervention in terms of network operation improvements. We heard about ADMS and OMS and also VAMs, PMU and VAMs as part of increased visibility of the situational awareness. Coming to the digital aspect of it, I will touch upon 2-3 key solutions where we talk about the maintenance aspect of it. While the network operation is important, it's also equally important to have proactive and predictable maintenance so that you can operate your assets in a more increased lifetime and reduce the failures of the assets. So that is where the AML model based the intelligence is coming in terms of the prediction of the fault or the health assets, and also not only knowing where the problem is, but also what kind of corrective action needs to be taken. So where the prescriptive assessment is done on the asset model, so you know where to hit the hammer when there's a particular problem. So when the field crew goes to attend the maintenance activities, so they don't carry out this standard checklist, but they know the problem and they carry the exact tools and the problems to be identified. And also the workflow process which is there, after the recommended actions which are there, so how to carry out the maintenance schedules, the plans, and also how to have the feedback mechanism from the field, so that the entire life cycle of the asset management is taken care. And also the maintenance versus the replacement priority assessment. So it's not only just to repair the asset, but also it's important to know when you have to replace, when you have to repair. So that kind of an analytic view of the models which are important, and also the prognostics capabilities where you can simulate a particular failure condition. Like if there's an asset, that there are parameters going into the warning zone or the high risk zone. So you can simulate a condition where you will come to know what is your operational condition that will leverage the asset to operate in a more optimal way, so that you don't get into a failure mode, but then you can convert your breakdown maintenance to a preventive maintenance. So these are the aspects when we talk about the AML models around the asset management perspective. The other one is the vegetation management, because that is also, so while the asset still forms the network, the vegetation is also another aspect where it can infringe into your transmission lines or distribution lines or the tracks as well, and then they can create an outage because of that. And there can also be safety aspects considering into that. So the image analytics comes a very important factor into this vegetation management, where you can forecast your growth patterns, the infringement clearances areas, and you can proactively plan your cutting or pruning of the branches, so that you don't allow the infringement to happen. So that can also be part of your proactive planning of the activities to reduce outage, as well as address the safety concern. And the other third and the last would be the energy markets, the energy trading and risk management. So when we say market, it is not only the pricing or the forecast of the generation and the demand, but it's also how do you manage the risk in the agreements. For example, there are PPAs, there are the commitments, generation and demand commitments are there. How do you manage those risks, and also have the price forecasting done into the into your planning portfolio, so that you are able to generate and also deliver what is exactly committed to the grid. So these are the different aspects when we talk about the digital intervention in terms of the operations and also the maintenance aspects of it. So more details, of course, I will be there available, and the slide deck is there for you to go through. Thanks.
Thank you, Mr. Vijay. Now, next I would invite Madam Anamika. Yeah, she is representing L&T, a well-known organization in power sector. And see what she is doing, probably that is the basic input for building up the smart grid and all AI-related technologies. So please enlighten us.
I'll keep it brief, but so I just wanted, before I start talking, I just want to briefly introduce what I'm doing. I'm part of L&T Semiconductor Group, and when the Prime Minister started the vision that we want to do India Semicon mission, two companies came up. I'm sure you've heard about it, Tata's and L&T. And I'm part of this team, the leadership team who has taken the pledge to create a global company out of India for semiconductors. But what differentiates us? And that's very relevant here, because we are in a show which is talking about energy. Now, all over the world, semiconductor companies are today focusing on industry or the automotive, but they do not, energy is just one offshoot, a small offshoot of their discussion. But what we decided, energy needs full-fledged focus, and we are having a vertical called energy. So, as we talked about, Anita ma'am, when she started, she said there was an outage many years back, and I'm so privileged to stand here. I worked with Mr. Kushwah many years back in PGCL with Atul Baliji. We created the first energy management system in 12 states in the country. We added in Tata Power the first outage management system. So technology has always been there, and it always has a solution. But today, it's unprecedented. When the country moves from, in 2030, we want to be 500 gigawatts, and we want to be 2,000 gigawatts in 2047, I think the challenges are Hercules. And that is where we need to see how this explosion of data, how everything else that's happening around the world can be taken care of. Now, from what we are looking at today, many things are changing. When we talk about data, we talk about AI. The important part is these data are housed in something called data centers. And these data centers with AI coming in need 5x more power. Then we are talking about electrical vehicles. We are talking about EV charging infrastructure. The requirements are going to, megawatts to terawatts. Digital manufacturing is led by robots. Cryptocurrency to blockchain. Everything exploding, and a lot of energy is required. But then there is limitation in existing systems. Somebody was talking a system about, India is today talking about transformers. Yes, the transformers have a lot of challenges today, and also we are having a demand-supply gap. I'm sure you have heard about CRGO, but is it also correct on a is it secure? Is it able to match the requirements of growing demand that you have? You're talking about evacuation at 1100 kV. With all this coming in, there's a huge turmoil that's going on. The infrastructure matching the requirements. And that is where we are talking about a solution where we can provide a solution which will match the requirements of software with hardware. Because every system that we today have, we talk about cybersecurity. It's important to understand what is cybersecurity. Your system can be hacked. That's as simple as it. But then the cybersecurity sits on a hardware which is called the chips. Now, if the chips are not commensurate with whatever you're doing in the software, I think that beats the purpose. And that is our endeavor today, that we are talking about DOS attacks, FDI attacks, JDA attacks. But those very, very softwares today are sitting on chips which are made elsewhere with our neighboring friends. I don't have to mention their names. You're under attack. You are under attack. And national security cannot be compromised. There's no amount of money, whatever you can save, can be compromised on national security. And that's the need of the hour, to create solutions and systems that are made in India, by India. The IPs have to be owned by the Indian companies. And that is our endeavor. We are creating solutions and systems that match your requirement. As we talk about HVDC, 1,20,000 crores is being spent on HVDC upgradation infrastructure by 2030. Have you calculated that the IGBTs, that's the semi-content that goes into it, is 15%. That works out to be 18,000 crores. Today you're working on a technology which is 40 years old, silicon IGBTs. And the latest technology is silicon carbide, which does not exist. And the sad part is, it's just 30% higher. And when you're spending 1,20,000 crores, all you need to spend is another 400 crores, and you will get the latest technology. And that is the need of the hour. That's what we are alluding, that let's go to the next generation. India is already 14 generations behind in semiconductor technologies. We'll keep going behind. But it's time for us to take the leap of faith and become ahead. And I would urge this esteemed gathering that let's think about technologies of the future. And I'm so glad to tell you that today Ministry of Power and other entities like Central Electricity Authority has really requested us to come and tell them the roadmap of the future for semiconductors. And I'm hoping that we'll be able to provide you the technologies of the future rather than going backwards or do backward integration. With this, I would like to tell you that every element of the system has to be taken care. I showed you a photograph of a transformer. Let me tell you, we can provide you solid state transformers, which are 30% lower in, I would say, footprint, but even 40% better in power efficiency. So if the requirement of the speed increases, we have technologies.
Please hurry.
So with this, I think I would, as we have paucity of time, I'll come to the end of it, but I will welcome each one of you. If you have any questions, feel free to get in touch with us. Thank you very much.
Thank you, madam. I know you. Now I invite Mr. John Grimes, the CEO, Smart Energy Council. Oh, I think he has already left. So next is Mr. Dharamveer Singh, founder and CEO, Power Exchange.
Good afternoon, everyone. My name is Dharamveer Singh. I am the founder of Power Exchange and CEO of Power Exchange. And I have one success story in India for the implementation of blockchain in the nationwide for the telecom sector. So under the Telecom Regulatory Authority of India, I have implemented blockchain technology in telecom sector in 2020 when lockdown was there. So by integration of this technology, we have saved the 500 crore plus yearly money for citizens by minimizing the spam and fraud management in the financial sector. And by implementing this platform, blockchain-based platform, we have also generated the 500 crore plus extra or additional revenue for the telecom operators. So for the emerging technology implementation, my perspective is little different. So whenever the integration of emerging technology needed, we need to evaluate the technology by perspective in the short term and the long term goals. And emerging technology adoption should not be taken as a burden for the clients or for the utility or the end clients. It should be taken as an opportunity where we can either be able to reduce the cost or either be able to boost our revenue. So such emerging technologies should be integrated in utility sector also. So we have come with the P2P energy trading platform called as a Power Exchange. So currently we started working in the Uttar Pradesh under the UPPCL. Recently we got the order for next 3 years to implement in all the 5 discoms of the UPPCL. So we are hopeful that in upcoming next 5 to 10 years, we will be able to generate the additional revenue for the utilities also, and by leveraging such technologies, by implementing AI and blockchain, the revenue will increase slowly. So I am the currently mentor of Center of Excellency of Blockchain in the STPI, Ministry of IT and Electronics also. And I am the member of Confidential Cloud Computing organization of the, this is the organization of Linux Foundation also. So I will take little less time because time is already there. So I think these points already covered by the panels.
We got the message, what we have done in telecom needs to be now.
Yeah, right. So just I will take just 1 minute more. So basically, currently my vision is I am building the India's first AI agent-enabled blockchain dedicated for energy sector, who have the capability of self-healing as per the use cases, which will boost the revenue as well as which able to save the cost for the utilities. We called PowerX network, and it will be a open source. And we are also partnering with the utility and organization for innovative use cases testing, and we are doing the testing and POC, which can contribute cost saving or revenue generation for the utilities.
Mr.
Okay,
Singh,
thank you
please.
so much.
Yeah, now I will invite Mr. Vasu Purana, is the last speaker.
Yeah.
Good afternoon, everyone. It's been a pleasure for me to be with such a esteemed group of technology innovators and experts. Lot of us talk already about digitalization and its AI and the IT part. I would like all of you to take on a different part of digitalization, which is towards the OT side. So in OT side, if you talk about AI, everything will be, every data will be coming from the OT side. Without OT side, you won't be able to, predict any, predict any AI, predict any, predictive measures cannot be taken. So if we talk about the digitalization, the critical enablers to be, this side is reliability, its availability, and its security. So we will focus only on the three parameters, that is reliability again, availability, and security. So in reliability, the main part is the scalability part. The system you are using, whether it is open for all. Now the industry is already IT specific. Whether the system we are using is IT friendly or not. Yes, it is friendly to the grid side or the OT side, but whether the system is friendly to the IT side or not. How AI is being done, like the higher end oriented language, C, C++, Python, etc., how it can be integrated to the current system, and how the system is open as per the IEC standards like IEC 61850, IEC 104, how it has been compatible with the system. If we talk about the reliability again, the predictive maintenance again will play a major role in the industry. In maintaining the asset life, in maintaining the asset health condition, these all can be done through the predictive maintenance in reliability. If we talk about the availability measure, which we already see how the availability of system will help the digitalization going forward. Now, how we use redundancy in every aspect, how we are going to save our system from the surges, how modularize system so that it can be used in the longer run of the life. So if we talk about the redundancy of system, we have to redundant every and each aspect of the system, whether it is related to the power supplies, whether it is related to the protection relays and the coupling relays, whether it is related to the, you can say, network redundancy. Now with...
Mr. Vasu, please try to close it within 30 seconds. We are startup time.
Okay, sir. So this is basically a network redundancy, how if we want digitalization, how the network will be redundant. Then again the lightning protection, how system will be going to protect from the lightning protection, which is a natural, natural form of event. Generally, we see a lot of our installed system got burned due to just surge protection, surges. Now, if we talk about the security measures, cyber security is play a bigger role. And we have seen already in India, a lot of attacks have been done on the Eastern Load Dispatch Center, SLDCs and Northern system. We also come across in daily life how the digital arrest is happening a lot. So being the power sector is the most critical sector with 71% of, at risk. So how this, you can say how it can be distinguished between the IT and OT. IT basically follows the confidentiality part and OT basically follows the availability part. So I think with not much time, we are present in the exhibition hall. Please do visit us, and we can discuss how we can achieve reliable and availability of the digitalization system. Thank you.
Mr. Om Krishna, yeah, please. Yeah. Mr. Om Krishna. Om Krishna.
Yes, yes. Yes. Oh. Yeah. So good afternoon to all of you. Myself, Dr. Om Krishan, I am from MIT. So I'm not going detail, just in interest of time, into what are the challenges and opportunities in digitalization of these utilities. So what are the solutions available, what the technology have been developed through the different program and scheme of Ministry of Electronics and Technology, that I'm just focusing. So these things already, what are the different technology, digital twins and all. So I'm going directly to the MIT initiatives. So in MIT, we have a program, National Mission on Power Electronics Technology. So focusing the different aspect of the power electronics, targeting to the different applications, renewable energy, microgrid, traction, e-mobility, LVDC, power distribution system, smart power quality centers. So various, lot of technologies have been developed related to the AMI, smart meter, and different type of power conditioning unit controllers, and that has been commercialized to many companies. So these are the industry partners and academic institutions that have participated across the country under this mission. So various technology, as I mentioned, that has been translated to the different industry for the commercialization. So apart from this power electronics, as mentioned by some of the speakers, like power electronics, communication and control of energy is the, very important aspects when we talk about the utilities and all. So these are the some electric vehicle because of the clean transition and all. So various technology related to motor drives, controllers, chargers have been developed under the one of the different program of electric vehicle subsystem. So there are some roadmaps. So these are NAMPET, more than 25 technology have been developed and it is being commercialized. As far as the, as Atul Bali sir mentioned, AMI and smart meter is as far as MIT is concerned, so in MIT, this smart meter, single phase, 3-phase smart meter has already been developed and more than 12 companies have taken that technology and they are commercializing. And apart from that, AMI infrastructure, including all that is head-end system, data concentration units, that has been developed, and queries are coming to take that technology, AMI especially. As far as these smart substations, so smart power quality centers has been developed, smart microgrid, interconnected microgrid has been developed through our one of the nodal centers, C-DAC Trivandrum. Our stall is here, so whatever the technologies that is already being displayed there. So all are invited to visit our stalls and check the technologies available indigenously. So I'm not going much detail, just this one. So I invite that whatever the indigenous technology, industries and come forward to take the develop the solution with the indigenous technologies and all. And if any new challenges and opportunities digitalization of this one, so collaboratively, ministry is open to develop the solution. So these are the companies that has been transferred the technology for a smart meter. So I think thank you very much. Thank you very much. If any queries, then all the details are available on the MIT website and C-DAC website also. So thank you very much.
Thank you. I wish I could have some more time. There is no time for question answer. So we are in hurry. I will request Madam Anita to state.
Needless to say, we have all seen time is the greatest and critical resource for all of us. What we have discussed, I think each one of us brought a very critical piece of our clean energy transition, the role of grids making being more smarter, more efficient, more reliable, more secure, and more stable, and safe also, and also self-healing, what we learned today. So going forward, if we really want to go and have the aspiration, national aspiration, fulfill those aspirations, we all need to work collectively. I think events like this give us some food for thought, but it really needs to be translated into actions. And today is the age when we are talking not only of AI, now it is when each, from generation to transmission to distribution, all infrastructure devices and to the end use, we all need to talk to each other. So communication really will be the key, and it has to be enabled through intelligence. So intelligence built around those communication is going to be the hallmark of the way entire, you can say, grid system will work. And we really need to enable these grids to be future ready. And future ready with all solutions, we need to really learn from some of the good practices being done. I happened to be in Brazil a few months back, and I saw the world's second largest 14,000 megawatt of hydel plant shared by two countries, Paraguay and Brazil, operating at different frequency, 50 hertz and 60 hertz. So, and the kind of the smartness they have brought in the grids. So that we need to learn, and how India can be a future major player in the energy domain. We really need to pilot these new initiatives, learn and actually discuss. Please, I would urge upon this Smart Grid Forum to really convene such kind of meetings with, where pilots have been deployed, and we learn from what are the good practices we can evolve for the future. With these words, I thank the moderator, Mr. Kushwah, and all the esteemed panelists who are from the country and outside the country, whether online, offline, and in physical mode they have joined, and all the participants who have been a patient listener. Thank you.
Thank you, madam. Thank you all the speakers and participants. Again, I would say that due to shortage of time, we could not take up the question answer, but we would be meeting outside the hall. Anybody has anything in mind, we can discuss with that. Just 2 points I will make. I wish I would have discussed in this before closing up that. See, one is that in my experience, the biggest hurdle in scalability of the software or the automation system as deployed in the power system has been its interoperability, the constant coming up because of that. See, the new developers, which some of them here, my suggestion would be that to develop the product in such a way so that they are scalable, they are interoperable. In fact, there is a organization under Mr. Anand, Mr. Neil Kearney, and there's a report has also come out. It is on interoperability for digital energy grid. And it is in partnership with IEA, International Energy Agency.
I think you're talking about a unified energy interface. Unified energy interface.
Ma'am, that's a technology. What you said, digital energy grid with IEA is a white paper, but actual first implementation of that in the world we are doing with FIDE and several other technology partners in Lucknow. It was supposed to be live by now, but because of March 31st pressure, we couldn't get what we wanted. So first of all, sorry for the delay, and lunch is kept up until 3:30, and the EV session which was supposed to be here, we moved to Crystal 1. So those who wanted to part of EV, please come to Crystal 1.
Thank you, everyone. I would request Ms. Reena ma'am to on stage to hand over the token of mementos to all our speakers, starting with Ms. Anita Gupta. Mr. A S Kushwah, Mr. Sridhar Venkat, Mr. Atul Bali. I would request panel come forward for group photo.